All right. Let's go on to 8.6. I don't think this is going to be too difficult. We're going to be talking more closely about these corresponding angles. And I mentioned these in a previous video, but we're going to be looking a little bit more clearly with what they actually mean. So let's say that when a line intersects with two lines that are parallel, then it forms the same angles with the first parallel line as with the second. So, excuse me, again, it kind of looks like this. If I drew an angle set out like this, and say I have two sets of parallel lines, and if I put my angle measures in like this, say I have 180, 80, and 100, 180, and 80, and 100. I can see that in this case, my similar angles, 80 and 80, are across from each other, and my other set of angles are here and here, are the same. But my corresponding angles are the angles that are on the second set of intersecting lines. And if I mark these as parallel, which I just did, I can see that now my corresponding angles go across and to different directions. So let's say I mark these as A, B, C, D, E, F, E. Oops, that should be an F, but that's just another E, G, H. I can see that A and E, angle A equals angle E, and they are corresponding angles. If I were to write all of my sets out, I could say A and E are the same, B and F, angle B equals angle F, angle C equals angle G, and angle D is equal to angle H. And these are all of my corresponding angles when I go through and match. And in fact, I can indeed see that these are the same, and they are equivalent to the angles on the side. So this set up here is completely the same as the angles set below, even though they are different named and different numbers. And again, what they're going to do is they're going to give us a set of this with some of these missing, and we'll need to figure out where these possible numbers go. But that's pretty much the biggest thing about these corresponding angles. Whenever we have parallel lines, it creates a whole set of these. Let me show you a quick example of how I could fill in an entire set just by knowing at least one of the angles. So for example, say I have my set like this. I'm going to draw out here. And say I know that this angle here is 70 degrees. And I know that my two lines are parallel. Okay, well, if I know that this is 70 degrees, I can certainly say that its vertical angle that is across from it, hang on, let me make sure I'm using the right words. I like to have my notes beside me so I don't say it wrong this time. Sorry. Oh, no, yep, my vertical angle, or my opposite angle, I can say, well, this is certainly going to be 70 degrees as well, because I know these to be the same whenever I look across from each other. Okay, so that means that here This is going to give me a adjacent angle. And then I can say this total is going to be 180 degrees. So 70 plus missing angle equals 180 minus 70. I can say that this is 110 degrees. Well, now I know that this is 100 degrees. Sorry. Should have written 110. Then, of course, this one here is also going to be 110 because it is the vertical angle across from it. Now, since all of these are corresponding angles, I can just simply map them over and across as long as I put them in the right spot. This here is going to be 110. Of course, I know that this is the vertical angle. It's also the corresponding angle, so I know this is also going to be 110. And then here is going to be 70 because of my corresponding angle. And then my corresponding angle, also my vertical angle, makes this 70 degrees. So simply from one angle, from the knowledge of one part of this shape, I can extrapolate and figure out all of the other pieces. And that's what's really cool about geometry and working with angles, is that we're going to discover that we have a lot of power to really figure out all the things that we need to do. Good luck, and if you need help, ask an adult or ask a friend.